Every single day you're having these conversations you probably don't even think twice about. With your phone, with your search bar, maybe even your email. This is all powered by a technology called Natural Language Processing, or NLP. And today, we're going to pull back the curtain on how computers are finally learning to understand our most human trait, our language.
I mean, really think about it for a second. You ask your phone for directions, Google practically reads your mind and finishes your sentence, a chatbot helps you track a package. It feels like magic, right? But it's not. So how in the world does a machine go from just a jumble of letters and words to actually getting the intent, the meaning, the context? Well, that's the core puzzle we're going to piece together today.
Here's how we're going to do it. We'll tackle this in 5 key steps. First, we'll cover the basics of language and machines. Then, we'll see where this stuff pops up in the real world. From there, we'll dive into how machines understand words, then whole sentences, and finally, we'll get to the revolutionary leap that powers the AI you hear about everywhere today.
So let's start at square one, the big, fundamental challenge. How do you teach something that only thinks in ones and zeros to understand something as messy, as nuanced, and, well, as human as our language?
The NL in NLP stands for natural language. We're talking about the languages that just grew organically, between people, like English or Spanish or Hindi. These languages are packed with ambiguity, slang, inside jokes, sarcasm, all the good stuff. It's a world away from a programming language like Python, which is all about being rigid, logical, and having absolutely zero room for error.
So, when you boil it all down, the entire field of NLP really has 2 simple goals. First, comprehension. Can the machine actually understand what you're saying? And second, generation. Can it then create a coherent, logical response? Basically, listen and then talk. That's the whole mission.
Okay, so where does this technology actually live? You might think of it as some far-off, futuristic thing. But I promise you, NLP is already woven into pretty much everything you do online. Seriously, from the moment your day begins, it's there. That spam filter that tidied up your inbox while you were sleeping, that's NLP. The grammar checker that made your email sound way more professional, yep, NLP. Your voice assistant that sets a timer, the search engine that auto-completes your crazy questions, even the tools that help companies sift through thousands of resumes. It is the quiet, invisible engine driving so much of our digital lives.
All right, time to pop the hood. This is our first real technical dive. How does a machine even begin to learn a language? It can't read a word like you and I do. It has to translate it into the only language it really speaks, math.
And this happens in 2 main steps. First up is tokenization. The machine just takes a sentence and breaks it into little pieces, or tokens. You can think of them like the Lego bricks of language. But then comes the real magic trick, embedding. Each one of those little Lego bricks gets converted into a very specific list of numbers, a vector.
And this idea, word embedding, is the absolute bedrock of modern NLP. It's everything. By giving every single word a unique numerical address, the machine stops seeing the word king is just 4 letters. It now sees it as a mathematical object it can actually work with, something it can compare and analyze in relation to every other word.
Now here's the really brilliant part. It's how these numbers, these vectors, are organized. Imagine a giant invisible map of meaning. Words that mean similar things are placed close to each other. So words like good, nice, and wonderful all huddled together in one neighborhood, while words like bad and worst are way over in a completely different one. This map is how a machine starts to learn, mathematically, what words mean.
Okay, so machines can understand individual words. That's a huge step. But language isn't just a bag of words, right? The order matters a lot. Dog bites man means something totally different than man bites dog. So how do these models handle sequence and context?
For a long time, the go-to solution was a model called a recurrent neural network, or an RNN. An RNN works kind of like we do. It reads a sentence 1 word at a time. And the key thing is, as it reads each new word, it keeps a kind of memory of the words that came before it. It's this memory that gives it the context it needs to understand the whole sentence.
But RNNs had a pretty big flaw. When you have a really long sentence, trying to cram all that meaning into one single compressed memory creates a bottleneck. Important details from the beginning of the sentence just get lost. And then came a massive breakthrough, the attention mechanism. Instead of relying on this fragile short-term memory, attention lets the model look back at every single word in the original sentence at once and decide for itself what's most important to focus on.
And this makes so much sense, doesn't it? It's exactly what we do when we're listening to someone talk. You're not holding on to every single word they said equally. Your brain naturally attends to the most important parts to get the gist. The attention mechanism was basically a way to teach machines how to do that same exact thing. It's much more efficient and much more human.
And this brings us to our final and honestly, our most important stop on this journey. Because this idea of attention didn't just improve the old models. Oh no, it made a completely new one possible. An architecture that would totally upend the entire field.
It's called the Transformer. And this single innovation is the engine behind pretty much every major AI breakthrough you hear about today, from Google Translate to the large language models that power all the modern chatbots.
So what made the Transformer so special? Well, first, it completely threw out that old one-word-at-a-time process. It could look at an entire sentence all at once, which made it insanely faster to train. It did this with an even more powerful idea called self-attention. This means for any single word, the model can instantly calculate its relationship to every other word in the sentence. This creates this incredibly deep, rich understanding of context that was just never possible before.
So there you have it. In just a few minutes, we've gone all the way from simple definitions to the complex architecture that really defines modern AI. We've seen how machines learn to stop just seeing letters and started to understand relationships, context, and true meaning. This journey has already taken us from clunky translation to the edge of truly natural conversational AI. And it leaves us with one last thing to think about. As this technology keeps getting better and better, what's the next big conversation we're all going to have with our machines? Thanks for joining us on The Explainer.